Everybody, welcome to my presentation, Consolidating Electromagnetic Waves from Separate Sources. The picture presented in this slide shows several light beams which emerge from a point in space and propagate into separate directions. However, it can also be used to demonstrate something else. It can demonstrate several light beams which emerge from separate directions and eventually consolidate into one consolidated light beam, which is a null wave which contains no electric and magnetic fields and thus disappear. Wow! Can this happen? I'd like to start the presentation by explaining why I was interested in the first place in the phenomena of consolidating of electromagnetic waves from separate sources. Actually, now I am retired electronics engineer. However, during the years I spent time in thinking about issues such as what might be the real nature of notions or entities that the science of physics invented, such as the electric charge or the energy. I arrived in some conclusions that are new and different from what nowadays physics agrees about these notions. I also noticed that if electromagnetic waves from separate sources can consolidate, this embeds paradoxes, but also might provide explanations to the way I understand these notions. So, I realized that the phenomena of the occurrence of consolidating of EM waves from separate sources is actually based on very sound argumentation, which might also support a much larger view of some entities, such as the electric charge or the energy, brought about by a new theory that I propose, whose name is the energy pairs theory. All that will be presented in the following slides of that presentation. So let's start with the following questions. 1. What are consolidating EM waves from separate sources? 2. Why it is important to study this phenomenon? This slide presents the initial qualitative scenario which might demonstrate what might be consolidating electromagnetic waves from separate sources. This scenario contains one electromagnetic wave source, source A. It also contains a separate electromagnetic source, source B. It also contains a half-transparent mirror. Source A emits an electromagnetic wave, wave A. Wave A passes the mirror as wave A1. Source B emits a second electromagnetic wave, wave B. It is deflected by the mirror as wave B1. And if wave A1 and wave B1 continue to travel on the same line or the same direction, they consolidate into one consolidating electromagnetic wave. So, consolidating electromagnetic waves from separate sources is unification of two electromagnetic waves from two separate sources, which continue to travel together on the same line and on the same direction. As will be demonstrated later in this presentation, if EM waves consolidation from separate sources can occur, the energy conservation principle seems to be violated, which sounds as a very severe paradox. This actually addresses the question asked why it is important to study EM waves consolidations from separate sources. This will be addressed in much more details later in the presentation. Now we will define the main claim of this research. The research claim is that electromagnetic waves from separate sources can and do consolidate. This is a very serious claim because if EM waves from separate sources can and do consolidate, this embeds paradoxes, and the acceptable notion today is that this cannot occur. An example of the acceptable notions today that EM waves from separate sources cannot consolidate is provided by an article by Kirk McDonald from Princeton University, whose link is provided, which states a one-dimensional wave moving in one direction can have only one source, and there can be only one such wave at a given point. This implies that EM waves from separate sources cannot consolidate. However, several articles published by me indicate that EM waves from separate sources can consolidate, even though such consolidations seem to violate the energy conservation principle. This is a very serious argument because energy seems to either disappear or be created out of nothing. In several following slides of this presentation, the seemingly energy conservation violations will be described in more details. However, the research provides scenarios how to implement EM waves consolidations from separate sources, and the research also describes common situations from everyday experience that anybody can experience, which might indicate that EM waves, for example light beams, from separate sources can and do consolidate. Actually, the necessary and sufficient conditions for two EM waves from separate sources to consolidate are as follows. The two EM waves must meet on a point in space, and after this meeting, continue to travel together on the same line and in the same direction. This actually assures the consolidation of these EM waves because EM waves in their wave facet are just traveling electric and magnetic fields, and electric fields that exist together at the same location in space annihilate each other fully or partially or sum up, depending on their polarities, to create a new consolidated field, and the same applies also to the magnetic fields. And because all EM waves travel at the speed of light, if the above-mentioned EM waves continue to travel together the same line in the same direction after they met, the electric and magnetic fields of the EM waves will always exist together in the same location in space, causing the above-mentioned consolidation to occur continuously after these EM waves met. An article published by me, titled Energy Analysis of Non-Electromagnetic Waves, presents a description of an experiment which uses a half-transparent mirror which might implement consolidations of EM waves from separate sources. This slide shows how a half-transparent mirror can be utilized to implement electromagnetic waves consolidation from separate sources. Wave A comes from the transparent side of the mirror and leaves the mirror. Wave B comes from a different direction, is deflected by the mirror, and after both waves leave the mirror, they travel on the same line and the same direction and thus consolidate. The occurrence of the consolidation of the two EM waves in the scenario just described is supported also by the superposition principle, because half-transparent mirrors are usually recognized as linear apparatuses. The superposition principle states that for all linear systems, the net response caused by two or more stimuli is the sum of the responses that would have been caused by each stimulus individually. So, if the experiment is first implemented with only one wave exists in it, the wave that passes the mirror, and then the experiment is implemented again with the second wave exists in it only, the wave that is deflected by the mirror, then when the experiment is implemented, when both waves exist in the experiment, the wave that passes the mirror and also the second wave which is deflected by the mirror and continues to travel on the same line or the same direction as the first wave travels after it leaves the mirror, the outcome of such experiment must result in the creation of a consolidated EM wave. In addition to the scenario just described, which utilizes a half-transparent mirror to create consolidations of EM wave from separate sources, the following slide will describe a photo that everybody can experience from everyday experience every day, which might imply that light beams, which are also EM waves from separate sources, might also be able to consolidate. This slide describes a glass-covered cabinet. It can be seen that things that exist inside the cabinet, behind the glass, such as the coffee pot, exist in this photo, and also the reflection of the person that took this photo, which stands in front of the glass, also appears in this photo. The following schematic describes why the photo presented in the previous slide indicates that light beams, which are also EM waves, from separate sources might consolidate. This schematic describes the following. Light beam A, which is emitted from the coffee pot inside the cabinet behind the glass, passes the glass as light beam A1. Also, light beam B, which is emitted from the person who stands in front of the cabinet in front of the glass, is reflected back as light beam B1, and light beam A1 and light beam B1 might be such that they are traveling on the same line in the same direction and thus consolidate. So, the photo described before might imply that many light beams like A1 might meet many light beams like B1, and some of these light beams might be such that they are traveling on the same line in the same direction and thus consolidate. Thus, the research claims that EM waves from separate sources can and do consolidate by presenting the following arguments that support this claim. 1. The research describes an experiment that utilizes a half-transparent mirror which might implement that scenario. 2. The occurrence of that scenario is also supported by the superposition principle. 3. The research presents a photo that indicates that light beams, which are also EM waves from separate sources, might also be able to consolidate. In addition, the paper presented in this conference in Chapter 4 provides additional arguments which might imply that EM waves from separate sources can and do consolidate. The slide up to this point in the presentation describes scenarios which should imply that EM waves from separate sources can and do consolidate. The following slides will demonstrate in more details why, if such consolidations occur, the energy conservation principle seems to be violated. This will also answer the question that was asked in the beginning of this presentation, why it is important to study consolidations of EM waves from separate sources. An electromagnetic wave in its wave facet is just two synchronized oscillating fields, an electric field and a magnetic field perpendicular to each other and traveling both at the speed of light. This slide presents one paradox of consolidating of EM waves from separate sources, mainly the creation of the null wave, which seems to embed no energy at all. If one wave meets another wave from a separate source, and after their meeting, these two waves unify and continue to travel together on the same line and on the same direction, then, if the waves unify when they oscillate at exactly the same frequencies, have exactly the same intensities in the electric and magnetic fields, are exactly at antiphase, which means 180 degrees phase shift as related to one another, and have proper polarization, then the resulted wave is a null wave that does not contain any electric or magnetic field. And since the energy embedded in an EM wave is proportional to the combined squares of the intensity of its electric and magnetic fields, then this unified EM wave seems to embed no energy, even though the EM waves that created it embedded energy. This schematic presents the intensities of either the electric or the magnetic fields of the unifying waves that created the null waves at the moment they unified. It can be seen that the electric field of one wave annihilates completely the electric field of the other wave, and the same applies for the magnetic fields of the waves. This implies that the fields of the resultant wave are zero, which implies also that its energy appears to be zero. However, it turns out that the creation of the null wave is not the only surprising and astonishing outcome of EM wave consolidations from separate sources. The null wave was created when the wave consolidated when they were exactly at antiphase. Because the energy embedded in an EM wave is proportional to the combined squares of the intensities of its electric and magnetic fields, then if the EM waves will consolidate when they are exactly at phase and not at antiphase, which means 0 degree phase shift as compared to one another, then the resultant wave will contain more energy than the combined energy embedded in the waves that created it. This is an even more astonishing outcome, because now it seems that energy was created out of nothing, and this is also a violation of the energy conservation principle. This slide presents an additional explanation to what was presented in the previous slide, in which energy seemed to be created out of nothing. In the creation of the null wave, the waves unified when they were exactly at antiphase. This means that the fields in these waves annihilated each other or subtracted from each other to create the fields of the null wave. However, in this scenario, the waves unify when they are exactly in phase and not at antiphase. This means that the fields in the waves add up to create the fields of the unified wave. So, if X is the intensity of the electric field of one wave, and Y is the intensity of the electric field of the second wave, then the intensity of the field of the resultant wave is X plus Y. Then, since the energy in an electric field is proportional to the square of its intensity, then X plus Y square is the energy in the resultant wave, X square was the energy in the first wave, and Y square was the energy in the second wave. And since X plus Y square is always bigger than X square plus Y square, then this seems as if energy was created out of nothing. However, the scenario of creation of the null wave, in which energy seemed to disappear, and the scenario of EM wave consolidations from separate sources when they were exactly in phase and in which energy seemed to be created out of nothing, are just extreme cases of EM wave consolidations from separate sources. However, in any scenario of EM wave consolidations from separate sources, the resultant EM wave embeds either less or either more energy as compared to the energy embedded in the waves that created it. This will be demonstrated in the following slides. This slide presents a schematic of unifying waves from separate sources that has an arbitrary phase shift at consolidation. It can be seen that in sections such as AB or CD, the polarity of one wave is the inverse of the polarity of the other wave. This implies that in such sections, energy seems to disappear. However, in other sections such as EF or GH, the polarity of both waves is the same. This implies that in these sections, energy seems to be created out of nothing. However, it can be evaluated that in such scenarios, the energy that seems to disappear is never equal to the energy that seems to be created out of nothing. This implies that in such scenarios, the energy embedded in the unified wave seems to be either less or either more as compared to the combined energies of the waves that created it. This slide is a schematic of unifying waves from separate sources that add different frequencies of oscillation at consolidation. It can be seen that in section AB, the polarity of one wave is the inverse of the polarity of the other wave. This implies that in this section, energy seems to disappear. However, in section BC, the polarity of both waves is the same. This implies that in this section, energy seems to be created out of nothing. However, it can be evaluated that in such scenarios, the energy that seems to disappear is never equal to the energy that seems to be created out of nothing. This implies that in such scenarios, the energy embedded in the unified wave seems to be either less or either more as compared to the combined energies in the waves that created it. So, from this slide and the previous slide, it can be concluded that in any EM unification from separate sources, the energy embedded in a unified wave seems to be either less or either more as compared to the combined energies of the waves that created it. From what was presented till now, it can be concluded that the research statement that EM waves from separate sources can and do consolidate relies on very sound argumentations, even though it implies a paradox, because the energy conservation principle, which is a cornerstone of science, seems to be violated if such EM wave consolidations does occur. However, the research also suggests a framework, which concludes that the energy is conserved after all, and there is no paradox, as is presented in the following slides. That framework is based on a new theory suggested by this research, the energy pairs theory. The basic premise of this new energy pairs theory is as follows. Energies embedded in EM waves or related directly or indirectly to an electric charge can accumulate or be stored together in pairs while disabling each other such that the energies exist but are untraceable or latent energy or exist as untraceable energy or dark energy. So, the new energy pairs theory presents a novel facet of energy, which is untraceable energy, which is latent energy that is also stored as energy pairs. And these latent energy pairs might be also related to the dark energy, which is still a mystery today. So, the new energy pairs theory elements are as follows. It expands the notion of energy to embed two facets of energies. One is detectable energy or traceable energy. Second is untraceable energy or dark energy. Also, the untraceable energy is untraceable because it is accumulated in pairs which disable each other from being detected. And the energy pairs theory also predicts that photons can carry both traceable and untraceable energies. Thus, based on the proposed new energy pairs theory, the paradoxes presented already in the EM wave consolidations from separate sources are resolved or explained as presented in the following slides. The new energy pairs theory predicts that the energy that seemed to disappear in the creation of the null wave is actually conserved as untraceable or dark energy in the photons of the consolidated EM wave. And the new energy pairs theory predicts that the energy that seemed to be created out of nothing when the EM consolidated when they were in phase is actually untraceable or dark energy embedded in the photons of the consolidated EM wave, which is converted back to traceable energy. However, the energy conservation paradox embedded in the occurrence of the consolidating of EM waves from separate sources is not the only paradox that gets explained or resolved by the new proposed energy pairs theory. Two additional puzzling questions are also explained by the proposed energy pairs theory. These two additional puzzling questions are: 1. Why in the famous mutual annihilation process electric charges disappear? 2. How come that electric charges are created from nothing in the inverse pair production process? In the mutual annihilation process, an electron and a positron annihilate each other to create photons, but the energy embedded in the masses of the electron and the positron is fully embedded in the energy in the created photons, and the charges of the electron and the positron just disappear. Where these electric charges went? How can basic elements such as electric charges disappear without leaving any trace of their prior existence? And in the inverse process, per production process, a photon in certain conditions converts back to an electron and a positron. But the energy in the photon is already fully embedded in the energies embedded in the masses of the electron and the positron. And the charges of the electron and the positron seem to be created from nothing. How this can happen? The new energy pairs theory resolves also these additional puzzles. It predicts that in the mutual annihilation process, the electric charges did not disappear. They were converted into untraceable or dark energy embedded in the created photons, similar to how the photons of the null wave embed the energy that seemed to disappear as untraceable or dark energy. And in the pair production process, the new energy pairs theory predicts that the electric charges that seem to be created out of nothing were actually untraceable dark energy that were embedded in the photon that was converted back into traceable energy embedded in the created electric charges. similar to the energy that seemed to be created out of nothing in EM wave consolidations where they were in phase. This might imply that a new and revolutionary conclusion or prediction of the new energy pairs theory might be that electric charges might be just forms of energy. Since, in the mutual annihilation process, electric charge and mass in the electron and the positron convert into a photon, which is just energy without mass and electric charge, and in the inverse per production process, a photon, which is just energy without mass and electric charge, convert into mass and electric charge in the electron and the positron. This might imply that mass, electric charge, and energy might be actually the exact same entity. However, mass was already recognized as energy after the introduction of Einstein's special relativity theory. And now, the new energy pairs theory might add to this conclusion that electric charges are also just forms of energy. And another significant prediction of the new energy pairs theory might be that most of the dark energy, whose origin is still a mystery, might originate from electromagnetism. My conclusion of the research is, since the research statement that EM waves from separate sources can and do consolidate relies on very sound argumentation, this scenario should not be ignored as it is still ignored today. Thus, the implementation of the experiment, as described in the research, to implement consolidations of EM waves from separate sources might be a very important endeavor. If this experiment will turn out to be successful, as my research predicts, then new and revolutionary insights regarding the notions of the electric charge and the energy might emerge. Also, significant technological achievements might be achieved. Thus, I will appreciate any support that I can get from anyone in the engineering or scientific community to join me and implement this experiment, which, as described before, might be a very important endeavor. Thank you very much for attending my presentation.